Okay, for tonight's homework 11.8, I'd like you to copy all this work, copy this graph best you can. Hopefully you have graph paper. Know that this is the key to the quiz problem that I graded in class today. So if you're not liking your quiz score, this will show you the work that you need to do to make up that quiz problem I'm grading. So here we go. Copy all this down, copy this graph, copy the 3 words. I'll make sure to give you 3 words today. Make sure. All right, here we go. First word right off the bat. First word is curiosity. Curiosity is the first word. All right, here we go. Domain. Domain measured from left to right, where my left and right boundaries slice through that x-axis. So it looks like -4, but because I have no boundary to the right, that's going to be infinity positive because this arrow is going off to the right. So for my domain, it's going to be square bracket because that endpoint is a solid circle, solid. That's why it's square. From -4, comma, infinity, rounded. Infinity always gets rounded. In set notation, -4 less than or equal to x less than infinity positive going to the right. Some people thinking since it's going down, negative infinity. But again, anything measured left to right, going to the right, positive infinity. All right, that is my domain. My range, I look at not the x-axis numbers for my borders, but I look at the y-axis. So let's clear some of this out. All right, here we go. My range, there is no bottom to my range. If this would have been a point right here, then my range would have been from the bottom from -3, where that bottom point slices through the y-axis, up here to 7. That would have been like square bracket from -3 up to 7 for my range if I was doing that with a solid circle there. But because there's not, and there's an arrow going down to infinity, there is no bottom to it. And since it's going down, that's going to be negative infinity because range measured bottom to top. Anything going down, negative infinity. So for my range, the bottom, no bottom, rounded, negative infinity, all the way up there to 7 on the y-axis. 1, 2, 3, 4, 5, 6, 7. Square bracket. If I did that, set negative infinity less than y less than or equal to 7. The second word is engagement. Engagement is the second word. All right, increase interval, where this stretch right here going uphill from left to right. Downhill is this stretch going downhill all the way there through that one section. So increase interval looks like from here where it starts to go up through -4 on the x-axis to right here it ends not going up anymore. So it looks like increasing goes from square bracket -4 to -1 square bracket. That's where it's going uphill. If I did that in set, -4 less than or equal to x less than or equal to 1. Decrease interval looks like it shares that same border of -1 right there, but since it's going off to the right, it's going to be positive infinity. Again, people look at it going down, but again, intervals like domain measured left to right, and anything going to the right, positive, anything going to the left, negative. Range is measured from the bottom to the top. So anything going up, positive infinity. Anything going down, negative infinity. Decrease in interval looks like it starts right there at that -1 to positive infinity. You don't want to break that down into two separates because that whole stretch from -1 to infinity going down. If I wrote that in set, -1 less than or equal to x less than infinity. Notice infinity never has the equal line under it. All right, maximum is the highest point. Minimum is the lowest point if there is a minimum. Sometimes you have these arrows going off to infinity forever, which affects if you have a minimum or a maximum. I think for this graph, because my arrow is going down, there's going to be no minimum, no catching the bottom point. But my top part though, right here, my highest point, my maximum, written as a coordinate. That looks like that is the coordinate -1 for x, up 1, 2, 3, 4, 5, 6, 7 for y, rounded because it's a coordinate. Minimum, none, because the arrow going down never is a minimum. -3, again, these are where I give you x and you use that to find y, or I'll give you sometimes y first to find the x number. So that first one, me giving you f of -3, that's me giving you x is -3. Find what the graph says y is when x is -3. So find this x-axis. This is your y-axis. Find -3 on your x-axis, and then go up or down until you hit that line. And when you come in contact with that line, look to the right and see what that y number is. So when x is -3, y is 3. The other one is me giving you the y number first. It's telling you that y is +7. Go to 7, not on the x-axis, go to 7 on the y-axis. 1, 2, 3, 4, 5, 6, 7. And then go left or right until you hit that line, and then look down right there, -1. So when y was 7 for this graph, the data is telling me x is -1, or if I had f of -1, that equals 7. All right, the third word is persistence. Persistence. Good luck. See you tomorrow.